Today we're looking at the graphs of sine and cosine. So we're going to be looking at functions where the input is some angle, and then the output of the function is the sine of that angle. And so we're going to do our angles in radians, and we'll be able to get a good idea from the shape of the graph just looking at these quadrantal angles here. Right? And so we're going to go back to our unit circle knowledge. So we're going to take a look at these angles on the unit circle. All right, so if we look at the angle 0, straight over here to the right, remember the unit circle had a radius of 1, so we want a distance of 1 to the side. So this point was 1, 0. And remember the sine of the angle is the y-coordinate, so sine of 0 is 0. And then we look at pi over 2. Pi over 2 is straight up. And so distance of 1 straight up, our point was 0, 1. Sine is the y-coordinate on the unit circle, and so sine of pi over 2 is 1. Okay? And so we're going to be able to fill out the rest of this table, and then of course this will give us points to graph here. Anytime we want to graph a function, this is always what we can go back to doing, filling out a table, graphing points. So for pi, we're looking at -1, 0, sine's the y-coordinate, 0, 3 pi over 2 straight down, 0, -1, and then 2 pi brings us back to the same point. Okay? These aren't the same angle, but they're coterminal angles. Coterminal angles, they're at the same spot, they have the same point, and so they have the same sine, cosine, and tangent values. Okay? So we can stop here because we're just going to start repeating now. So this graph is going to be just repeating infinitely the same values over and over and over again. Okay, so let's graph these points that we got here. We've got 0, 0, and then we've got pi over 2 halfway to pi, and then 1, and then pi 0, and then 3 pi over 2, 1.5 pi is right in the middle here, -1, and then at 2 pi we're back where we started. Okay, so it's going to kind of bounce around, and then it's going to keep doing that same pattern here. Okay, so this is the graph that we've got so far. And it's just going to keep bouncing around like that, going on forever. Okay? Again, when we got to 2 pi, it was back to 0. 2.5 pi's would be the same point as half a pi. 3 pi, same thing as pi. These coterminal angles, these angles are coterminal. They land in the same spot. They're going to have the same sine value. So it's just going to keep repeating forever. It's going to follow the same pattern here. So we've gone down, and now we're going back up again. This point would be up here. When you're at the top of the graph, you have to come back down to the middle of the graph here. And so it's going to keep going forever like this. And then back the other direction. Okay, we've gone up, and so now we're going down. So we'd have a point down here. At the bottom of the graph, you have to keep going back up to the middle, have a point right here. So the graph is going to keep just bouncing around forever like that. Okay, and so the domain, well, it's going to keep going on forever in both directions. The domain is all real numbers. We can find the sine of any angle. That was the idea of looking at the unit circle, that section we have of extending trigonometry beyond right triangles. We can find the sine of any angle now. So domain is all real numbers. How about the range? There's only a limited kind of y values that we can have in this graph, right? The y values have to be between -1 and 1, which makes sense if you think about the unit circle. The sine is the y value on the unit circle. Well, the highest y value we have is 1. The lowest value we have is -1. All the y values on this circle are between -1 and 1. So the sine of any angle has to be between -1 and 1. Okay. Now, because this graph repeats forever, we have something that we call a period. So things that are repetitive can also be called periodic. Regular repeated things are periods. And so one period is one section of the graph that repeats. So we looked from 0 to 2 pi. That was one section of the graph. We call that one period. Okay. We also talk about the amplitude of the graph, how high the graph goes from the middle section. So if we look from the middle of the graph to the top of the graph. That's called the amplitude. Okay. We also talk about frequency. Sometimes frequency is 1 over period. So amplitude and frequency, those are your radio stations, AM and FM. Amplitude modulation and frequency modulation. So we've got lots of these different words and things for these graphs because these graphs show up all over the place. Sound waves are trig graphs, are sine and cosine graphs. Electricity behaves like sine and cosine graphs. The tides, all kinds of different things. There's lots of places in the natural world that follow the same kind of pattern that can be represented in terms of sine and cosine graphs. I have a friend who worked for SDG&E who said that half of his job was just kind of playing around with trig functions, with trig graphs. These show up all over the place. Right? So it's good to know these well and some of the terminology for them. So we took a look at the graph of sine of x. Why don't you go ahead and try the graph of cosine x? Again, anytime you don't know how to graph something, just go back to making a table. So fill out that table. Remember that cosine is the x coordinate on the unit circle. Fill out the table, see if you can see what you think the graph will look like. See if you know what the domain and range for that function would be. You go ahead and give cosine of x a try. So your graph should have looked something like that. It's very similar, right? It does the same thing of just bouncing between -1 and 1. We've got the same domain and range. Same domain and range. It's just that sine starts at 0. Sine of 0 is 0. Cosine starts at 1. Cosine of 0 is 1. But then they both still just do this kind of this bouncing around pattern. So they both look very similar. So to keep them straight, it's very important to remember sine of 0 is 0. Sine starts at 0. Cosine of 0 is 1. Cosine starts at 1. That's the main difference between the two graphs there. All right, so then we're going to do what we've done with every other basic graph that we've learned. We're going to do transformations. Okay? Take the base graph, the parent function, and do different transformations and see what that does to the graph. All right. So let's try this one here. So we've got a number out front, and we've got a number inside, okay? We'll remember things out front affect the y's, okay? So if we start with y is sine, well, if we multiply that by 0.75, we're taking the y values, we're taking the sines, the outputs, and multiplying them by 0.75. So that's going to change our y values. Now, instead of our y values being from -1 to 1, our y values are going to be from -0.75 to 0.75. Okay, so that's going to affect the amplitude. The number out front is going to determine what the amplitude is. Okay? Instead of going all the way up to 1, it'll kind of vertically shrink it. It'll vertically shrink it down to just a little bit smaller. Okay, so we've got an amplitude of 0.75. Okay. Now the 2 is next to the x, so the 2 is going to somehow affect what's going on with the x values of the graph. Okay. So that's going to affect the period. It's going to affect what x value it takes to get one full cycle of the graph. All right. Now, if you like to memorize formulas, there's a formula for you. What I usually think about, though, because I don't like to memorize things, I know that the period is usually 2 pi. So, like when what's behind my finger is 2 pi, that should be the end of the period. That should be a full cycle. Right? So when 2x equals 2 pi, that'll be the end of the period. So I solve this equation here, and I get x equals pi. Right? So when x equals pi, when I plug in pi to the whole function, I actually end up plugging in 2 pi to the sine function. That's what I'm looking for. What x value makes me find sine of 2 pi? And that will be the end of the first period. Okay? So to graph this here, okay, this is a sine graph. So remember, the key thing is to remember where the graph starts. Sine of 0 is 0, so sine starts at 0. That's not going to change. 0.75 times 0 still be 0. Okay? And then the period is pi, so it's going to end at pi. Now, these always start and end at the same place. Right? When you're graphing one period of the graph, it should start and end in the same place. Okay? And then from there, Well, we've got 4 tick marks here to pi, so there's kind of 4 nice points in the cycle here. From where we start, we go 1, 2, 3, 4 is the end of the cycle. And so we take pi and divide this period, divide this length up into 4 sections. And conveniently, we've already got 4 tick marks for that. It's already divided up nicely. Okay, but the middle of the graph would be here at pi over 2, and then pi divided into 4 sections. This one will be pi over 4. So I'll have pi over 4, pi over 2, 3 pi over 4, and then pi will be where our points are. Okay, and then so sine, we're going to go the next point, we went up, we just kind of bounce around now, right? So we're going to go up, but instead of going up to 1, we're going to go up to 0.75. Okay, and then now we're at the top of the graph, so we only have, all we can do is go down. Got to go back down to the middle first at 0, and then we keep going down until we reach the bottom of the graph, but instead of going to -1, now we're going to go to negative 0.75, and then once we're at the bottom of the graph, we've got to go back up. Okay, so here is one period of the graph. Okay. If we want to graph more of it, we just keep going. We just follow that same pattern here. Okay, so I was at the bottom of the graph, so I had to go up. I went up to the middle, so I just have to keep going up to the top right here. And then once I'm at the top, I got to go down, middle, and then bottom. Once I'm at the bottom, I go back up. Okay, and so a full period of the graph should start and end at the same place, and it should have one maximum and one minimum. One period has one maximum and one minimum and starts and ends at the same place. Right? So now we've graphed 2 periods. If we needed to go backwards, we could just do the same thing going backwards. If you kind of go backwards, okay, here's the top of the graph, we go down to the middle, and then down to the minimum there. We're at the bottom of the graph, so now we have to go back up to the middle, keep going up to the top of the graph. Once we're at the top, we have nowhere to go but down. There we go. Started and ended at the same place, one maximum, one minimum. So we've graphed a full period here. So now we have 3 full periods of the graph. All right, that's what this graph looks like. Okay, let's try another one. Right, so this one has a negative, so just like every other function, the negative out front is going to change the y's between negative and positive. So negative y's, by which, of course, I mean the opposite. The y's change between negative and positive. Okay, so that's going to reflect about the x-axis. If we change y values between negative and positive, it reflects about the x-axis. Okay? This number out front changes the y values. Now we've got an amplitude of 2. And then for our period, we're going to take x over 2 and set it equal to 2 pi, multiply both sides by 2, and now our period is 4 pi. Okay? All right, now this is a cosine graph. So the cosine graph is not going to start at 0, 0. Cosine normally starts at 1, but now it's a little bit different. Instead of bouncing between -1 and 1, it's going to bounce between 2 and -2. Okay? So if it were 2 cosine x over 2, I would start the graph up here at +2. But because of that negative, I have to reflect it. Now I'm starting at -2. Okay? So normally I would start at 1. That gets multiplied by -2. So now I'm starting at -2. Okay? Very important that you get the starting point correct. If you get the first point or two correct, you're usually good. Then you can just kind of bounce around. Okay? All right, and then my period is 4 pi, and so I'll start and end in the same place. So I'm going to put a point right there. Okay, and then let's try to find where all the other points are going to be. Okay, so the halfway to 4 pi is 2 pi, and then halfway to 2 pi right here. I'll be pi. Makes sense because, again, we need 4 points. So if I'm going all the way to 4 pi, each one is going to be 1 pi, 1 pi, 2 pi, and then 3 pi right there. Okay. All right, so this is the bottom of the graph now because we're bouncing between -2 and 2. So the bottom of the graph, I have to go up to the middle and then keep going up to the top. And then if I'm at the top, I've got nowhere to go but down. So now go back down to the middle, and keep going down to the bottom of the graph. Okay. Now, when you draw your arrows here, you can't go past -2, right? This is the bottom of the graph, so you want to kind of draw a curvy arrow up like that. This is the bottom of the graph, so beyond that, it would kind of be bouncing back up there. So, draw this. This is just one period of the graph, but that's often enough. Would look something like that. Okay. Why don't you try this next graph yourself here? So take note of all the transformations. Make sure you take note of whether it's a sine or a cosine graph to know where to start the graph. Again, that first couple points, the first point or two, is very important. Think about the amplitude, think about the period, any other transformations, and sketch. You can just sketch one period of this graph. Right, so this is what your graph should have looked like. So a couple tricky things with this. One thing, the period was a little bit funky. I spaced out for a second when I was finding this. So I had to scratch a couple things out. The period was 3 pi. So then to figure out where your other points were, one thing you could kind of do the half and half again thing. You could find halfway to 3 pi is 1.5 pi, and then just kind of figure out the halfway point there. Or again, you could think about there's going to be 4 points, so 3 pi divided by 4. You're looking for 3 pi over 4, 3 pi over 4, and then count kind of 3 more each time, 3 more tick marks. So that was a little bit tricky. Also, the negative sign graph sometimes gets people a little bit. So it still starts at 0. Sine of 0 is 0. 0 times negative 1.5 is still 0. But then from there, it's going to go down because that negative we're reflecting about the x-axis. And so instead of going up, now it's going to go down. Normally, the next point would be up at 1. 1 times negative 1.5. The next point is at negative 1.5 there. Okay. So now we've got one more type of transformation to look at, right? So what if I have a -5 plus this? So I take all the y values of this graph and I add -5, right? Well, if you take all the y values and add -5, make them 5 less, the graph is going to shift down. All right. So actually, the easiest way to do these is just to go ahead and do it in 2 steps like that. Graph this, and then just take every point and shift it down 5. Okay. You can try to do it in 1 step, but if you think you can handle it, if you think you can figure out where all the points are going to be, but if you have any trouble at all, just do it in 2 steps. First, just go ahead and graph y equals 2 sine x. And then second, after that, just take every point and shift them down 5. Okay, so y equals 2 sine x, the amplitude would be 2. Sine graph, sine is 0, 0, so we would be starting at 0. And then let's see, we didn't change the period here at all, right? So the period would still be that basic 2 pi period. So we would go out to 2 pi right there, start and end in the same place. And so then this would be the halfway point at pi, right? The scale was pi over 2 for the base graph. We were using those quadrantal angles, 2 pi divided by 4, going to pi over 2 for our next point. Okay. And so we would go up to 2, and then back to the middle, and then all the way to the bottom of the graph. And then we do end up at the same place there. Okay, so if I connect the dots there, that would be y equals 2 sine x. So then I just take each one of those points and shift them down 5. So 0 minus 5 is -5. 2 minus 5 is -3. 0 minus 5 is -5. -2 minus 5 is -7. 0 minus 5 is -5. Okay. And then don't forget to connect the dots there. And that's what this graph would look like. Okay. So if you'd wanted to do it in 1 step, you'd have to think about, well, normally it would be -2, 0, and 2. And so then subtract 5 from all those and figure out that it bounces between -7, -5, and -3. So why don't you go ahead and try this next problem now. If you have any doubts of what it's going to look like at all, then I recommend, again, do it in the 2 steps again. First, graph it without the shift, and then take each point and do the vertical shift from that point. Or if you're feeling brave, you can try to do it in one shot. It's up to you. But go ahead and try this next graph on your own. All right, so that's what this one would look like there. Again, always make sure you're thinking about whether it's sine or cosine. Make sure you realize this was cosine, and so you had to start up at the top of the graph there, up at 3, um, before the shift. And then once it moves up 2, that one goes up to 5. And so the points bounce between 5 to -1, and then back to 2 and 5 there.